Hello everyone, I hope you like my first video on finding domain and range. Today we will be practicing a few more questions on domain and range. Okay, so this is the first set of questions in which we will be finding only the domain. Okay, so let's start. We need to find the domain of this particular function. So for finding the domain, we already know that anything inside the root will be always positive. Okay, which means that x minus 1 over x minus 2 into x plus 3 will be greater than or equal to 0. Okay, which means that this numerator upon denominator needs to be greater than or equal to 0, which gives us two cases. Case number 1, which says that numerator shall be greater than 0 and denominator also shall be greater than 0, not equal to 0, because denominator cannot be equal to 0. Okay, and case number 2, it will be both numerator and denominator are less than 0. Okay, why am I taking two cases? Clearly this fraction needs to be a positive value. So for positive value, both numerator and denominator needs to be positive, or both numerator and denominator needs to be negatives. So our final answer will be either case 1 or case 2. We need to combine both the cases. Okay, so one by one we'll solve both the cases. So for case number 1, we clearly have that numerator is greater than equal to 0 and denominator is also greater than 0. Okay, which means that x minus 1 is greater than or equal to 0, which gives us x is greater than or equal to 1. Okay, next we have x minus 2 into x plus 3 is greater than 0. So for finding the x values, we'll make the number line. We have minus 3 and 2 as two critical points. So let's take a number beyond 2. Let's say 3. Okay, so 3 minus 2 is positive, 3 plus 3 is positive. So positive into positive is positive. Okay, similarly, let's take a number between minus 3 to 2. Okay, so let's say 0. 0 minus 2 is negative, 0 plus 3 is positive. So negative into positive is negative. Let's take a number before minus 3. Let's say minus 4. Minus 4 minus 2 is negative. Minus 4 plus 3 is negative again. Okay, so negative into negative gives us a positive number. So here it will be positive, and we need only the positive portion, which means that we'll take this as well as this particular region. Okay, this says that x is less than minus 3 or x is greater than 2. Okay, so what do we have? Numerator and denominator are greater than 0. Clear? So and means intersection. So we'll take intersection of these two regions. Okay. So while taking intersection, we'll make a number line, and we have three critical points: minus 3, 1 and 2. Okay. This, first of all, this says that x is greater than or equal to 1, and this says that x is less than 3 or x is greater than 2. Okay, so we need the intersection portion, which means this is your intersection region. This gives us that x belongs to 2 to infinity. Got it? Now let's do case number 2. Now we'll do case number 2. Case number 2 says that numerator is less than or equal to 0 and denominator is also less than 0. Got it? So which means that x minus 1 is less than or equal to 0, which means x is less than or equal to 1. Okay. Next, x minus 2 into x plus 3 is less than 0. Okay, which says that we have two critical points again, minus 3 and 2, which means again positive, negative, positive, but now we need the negative portion only, which means that x lies between minus 3 to 2. Okay, so for the final answer, we need to combine both of them. We need to take the intersection of both the regions. Now we'll make the number line. We have three critical points again: minus 3, 1 and 2. Got it? So this says that x is less than or equal to 1. Okay, and this says that x lies between minus 3 till 2. Okay, now we need the intersection region because it is written and in between. So this will be your intersection region. So this gives us that x belongs to minus 3 till 1. minus 3 excluded and 1 included. Okay. So what will be our final answer? For final answer, it's either case 1 or case 2. And or means union. So we'll take the union of this and this. So our final answer becomes x belongs to minus 3 till 1 union 2 till infinity. Got it? So this is your whole solution of this particular function. Okay. All right. So let's move on to another question. So here we need to find the domain of this particular function. Again, anything inside the root needs to be greater than or equal to 0. Okay, so let's solve it. Now we have that x is greater than or equal to under root of 1 minus x square. Now we'll do squaring both the sides. We get x square is greater than or equal to 1 minus x square, which makes it as 2x square minus 1 is greater than or equal to 0. Now take 2 common. We have x square minus 1 over root 2 whole square is greater than or equal to 0. Now we'll apply a square minus b square over here and we get x minus 1 over root 2 into x plus 1 over root 2 which is greater than or equal to 0. Okay. Now we'll make the number line for this. We have minus 1 by root 2 and 1 by root 2 as two critical points. Okay. So anything beyond 1 by root 2 will be positive. Here it will be negative and here it will be positive again. Okay. Now we need the positive portion. So we'll take this and this particular portion. Okay. And what we have is x belongs to minus infinity to minus 1 by root 2 union 1 over root 2 till infinity. So is this our final answer? No. This is not our final answer. For finding the final answer, we need to look at this particular value as well. Okay. So this is also a root. This question is basically root inside a root. So we need to make sure that 1 minus x square also needs to be greater than or equal to 0. Okay. So which makes it as x square minus 1 is less than or equal to 0. Now a square b, we'll apply a square minus b square and we get x minus 1 into x plus 1 is less than or equal to 0. Now we'll make the number line again. We have minus 1 and 1 as two critical points. So anything beyond 1 will be positive, negative, positive, and we need the negative portion. So we'll take this particular region. Now this means that x belongs to minus 1 till 1. Okay. So for the final answer, we need to take the intersection of this and this particular region. Okay. So let's see what will be the intersection. So for intersection, we have 4 critical points. Minus 1 over root 2, 1 over root 2 and 1. Okay. So this says that x belongs to minus infinity till minus 2, minus 1 by root 2 which is included and 1 by root 2 till infinity. Got it? And this says that x belongs to minus 1 till 1. And we need the common portion of the two. Okay, we need the intersection. So it will be this and this. Okay, we'll take the intersection of these particular region. So our final answer will be x belongs to minus 1 till minus 1 by root 2 union 1 by root 2 till 1. But is this actually our final answer? No. Why? Here's one more catch, and that is, let's take x, any value between this. Okay, so let's say x is equal to minus 1. Okay, so let's put x equal to minus 1 over here. What do we get? We get minus 1 minus under root of 1 minus 1, which makes it as under root of minus 1, which says that we have an imaginary term over here, but we can't take that. So we need to ignore all the negative values from this particular domain. Okay, so your final answer becomes 1 over root 2 till 1. So this is your final answer. Okay. I hope this question is clear to each one of you. All right. Okay. All right. So let's try another question. Okay. So we have two root here. One is this and one is this, and both the functions are get added. Okay. So let's solve. First of all, anything inside the root which is 4 minus x needs to be greater than or equal to 0. Let's take minus common. We get x minus 4 is less than or equal to 0, which makes it as x is less than or equal to 4. Okay. Okay. So first of all, we'll take this, and next here also clearly see x square minus 1 will be greater than 0, not equal to 0, because denominator cannot be equal to 0. So we get x minus 1 into x plus 1 is greater than 0. Okay. Now we have two critical points, minus 1 and 1. Okay. So here we'll get positive, negative and positive. And we need the positive region only. So it is this and this, which makes it x is less than minus 1 or x is greater than 1. Okay. So for the final answer, we'll take the intersection of these two particular values. Okay. So let's solve it. So let's take the intersection. We have three critical points, minus 1, 1 and 4. Okay. So this says that x is less than or equal to 4, and this says that x is less than minus 1 or x is greater than 1. Okay. And for our final answer, we need the intersecting region. So it will be this or this. Okay. So the final domain becomes minus infinity till minus 1. Okay. Union 1 till 4. Okay. So this will be your final answer. All right. I hope this is clear to everybody. Okay. All right. Okay. So let's try a few more questions. Now, next set of question in for these particular question, we need to find both domain as well as the range. Okay. So let's do one by one. Okay. So first of all, we'll find the domain and range of f of x is equal to modulus of x minus 3. Okay. So for finding the domain, clearly any real number would satisfy this particular function. So the domain becomes all real numbers. Clear? And for the range, do you know how to draw this graph? So let's first draw this graph. The critical point will be x equal to 3. Okay. So the graph of this particular function will become like this. Okay. So for range, we need the y values. Clear? So what will be the range? It will be 0. It will be, see the y values, it will be 0 till infinity. Got it? So the range becomes 0 included till infinity. Okay. I hope the range is clear. All right. Okay. Next question. Again, for finding the domain. What will be the domain? Domain will be all real numbers. Okay. Let's find the range. Okay. So for finding the range, let's first draw this particular function. Okay. So first of all, we'll draw f of x is equal to modulus of x minus 2. Okay. So clearly, the critical point will be x equal to 2, and this will be the function. Okay. Next, now let's draw f of x is equal to negative of x minus 2. Okay. So for the negative portion, we'll take the mirror image. Okay. So now the function becomes like this. Now 2 goes here and it looks like this. Okay. Now let's add 1 here. Okay. So now it becomes 1 minus modulus of x minus 2. So we'll add 1 over here and we get x equal to 1. Here it is 2 and here y is equal to 1. Okay. Sorry. Here we'll take positive 1. Okay. So 1 point lower like this. Got it? So what will be the range now? Clearly the function goes from minus infinity till 1. So your range will be minus infinity till 1. But make sure in your exam you need not draw the graph. So how will you represent this particular the range of this particular function? So let's solve this and find the range. Okay. So this is through graph, and let's see that how we'll represent our answer in our exam. Okay. So first of all, we know that modulus of x minus 2 is greater than or equal to 0. Got it? So minus of modulus of x minus 2 will be less than or equal to 0. Okay, so let's add 1 on both the sides. 1 minus modulus of x minus 2 will be less than or equal to 1. And this is nothing but your f of x. So f of x is less than or equal to 1. Okay, so from here also range becomes minus infinity till 1. Got it? Okay, so this is basically for your knowledge, and this is how you will represent in the exam. Okay, I hope this is clear. Very nice. Okay, so let's now find the domain and range of this particular function. So for finding the domain, we already know that the denominator cannot be cannot be equal to 0. Okay. So x minus 4 will not be equal to 0, which means that x is not equal to 4. So what will be the domain? Domain will be all real numbers except 4. Got it? Okay. Now let's find the range. Okay. Let's find the range. Okay. So for finding the range, we already know that for x greater than or equal to 0, modulus of x minus 4 will be x minus 4 only. It will be a positive. It will be a positive value, and it is being divided by x minus 4. Okay. And when x is less than or equal to, sorry, when x is greater than or equal to 4, we get this. And when x is less than 4, we get a negative of x minus 4 over x minus 4. Okay, so these two will be the f of x of this particular function, which makes it as f of x will be equal to, let's solve it, it will be 1 when x is greater than or equal to 4 and minus 1 when x is less than 4. Got it? Okay, so this gives us that your range will be equal to only two values, that is minus 1 and 1. Got it? Why is it so? Because when x is lesser than 4, then the output is minus 1, and when x is greater than or equal to 4, then the output is exactly equal to 1. Okay, so in range we have only two values, those are minus 1 and 1. Alright, I hope till here everything is clear. Okay. Okay, now let's practice few more questions on finding domain and range. Okay. Okay, so first question, here we have f of x is equal to 1 over x plus modulus of x. Okay, so let's first of all open the modulus of x. Modulus of x is x when x is greater than or equal to 0, and it is minus x when x is less than 0. Got it? So let's put those values in this particular function. Okay, so f of x becomes 1 over x plus x for x greater than or equal to 0, and 1 over x minus x for x less than 0. Got it? So this gives us that f of x will be equal to 1 over 2x when x is greater than or equal to 0, and 1 over 0 when x is less than 0. Okay, so when x is less than 0, we are getting 1 over 0, which is not defined, obviously. Okay, because 0 cannot come in the denominator. So clearly f of x is equal to 1 over 2x when x is greater than or equal to 0 is the only possible value, of f of x. Okay, now we'll start finding the domain and the range. Got it? So for finding the domain, we need to see the x values. Clear? So for finding the x values, clearly we get that for this clearly shows that domain will be equal to, here the domain will be equal to, 0 till infinity. Infinity is not included, and 0 is in fact not included. Why 0 is not included? Because clearly denominator cannot be equal to 0. Therefore, we cannot put x, we cannot take x as 0. Okay. Now let's find the range. Okay. So for finding the range, I have already told you that you need to take f of x is equal to y, which gives us that 1 over twice of x is equal to 1. We need the y value. We already know that x is a positive number, right? X lies between 0 till infinity. So x is a positive number, and if we multiply it with 1 over 2, which is also a positive number, so y will also will be a positive number only. Okay. So the range becomes 0 till infinity only. Okay. Clear? Okay. I hope this is domain and range is clear to everybody. Good. Okay, next, again, first of all, we'll redefine this particular function as well. So for redefining, we have that f of x is equal to 1 over x minus x for x greater than equal to 0 and 1 over x plus x for x less than 0. Okay, further we have 1 over 0 when x is greater than or equal to 0 and 1 over 2x when x is less than 0. Clearly, only f of x is equal to 1 over 2x for x less than 0 is the only possible value. Okay. So, f of x is equal to 1 over 2x for x less than 0 is the only possible value. Got it? So, now we'll find the domain and the range. Okay. So clearly domain will be x less than 0, which means minus infinity till 0. Okay. Now let's find the range. So for range we have f of x is equal to y, which means 1 over 2x is equal to y. Now we already know that x is a negative value and any negative number multiplied by a positive number will always give us a negative number only. So the domain will also be minus infinity till 0. Got it? I hope this is clear to everybody. Great. Okay. Third question. Again, we'll firstly redefine this particular function. So for redefining, we get that f of x is equal to 1 over under root of x plus x when x is greater than or equal to 0 and 1 over under root of x minus x for x less than 0. Okay. Further, we get 1 over under root of 2x for x greater than or equal to 0 and 1 over 0 for x less than 0. Again, only f of x is equal to 1 over under root of 2x is the only possible value. Okay. So, we'll write it f of x is equal to 1 over under root of 2x for x greater than or equal to 0 is the only possible value. Okay, I hope this is clear. Great. Okay, so let's firstly find the domain. So for finding the domain, we have x is greater than or equal to 0. But again, denominator cannot be equal to 0. Therefore, we can't take 0 as x. Okay, so your domain will become 0. Your domain will become 0 till infinity. Got it? Next, let's find out the range. So let's find out the range. Okay. So for range, we have let f of x is equal to y. Next, we have 1 over under root of 2x is equal to y, which makes it as 1 over 2x is equal to y square. So the value of x is now equal to 1 over twice of y square. Clearly, y can be any number because except 0, other than 0, y can be any real number. Got it? Okay, except 0, y can be any real number, but also we need to make sure that y is a root. Okay, y is root, so it will only be a positive real number. Okay, so your range becomes 0 till infinity only. Okay, why? Because y will be positive because it is a root, firstly, and secondly, y cannot be equal to 0. Therefore, it will also be 0 till infinity. Got it? I hope domain and range of this particular function is also clear to everybody. Great. Okay, next. So now let's find the domain and range of this function. We have f of x is equal to 1 over under root of x minus x for x greater than or equal to 0 and 1 over under root of x plus x for x less than 0. Got it? Further, we have 1 over 0 for x greater than or equal to 0 and 1 over under root of 2x for x less than 0. Okay, all right. So now clearly look at this, that only f of x is equal to 1 over under root of 2x when x is less than 0. Is this a possible value? Think carefully that is this actually a possible value? This says that when x is a negative number, then only this f of x can exist. Let's take x as minus 1. So what will be f of x? F of x becomes 1 over under root of minus 2, which does not belongs to the set of real numbers. Hence, we can say that neither domain nor range is possible of this particular function. Okay, I hope the concept of domain and range is clear to everybody. Okay, so if it is clear enough, so here are a few more questions for you all to practice at your home. So I have provided all the questions as well as all the answers. In case you have any doubt, you can let me know. Okay, thank you so much for watching.